Hello everyone, I am Sabib from ACE Academy. Today I'll be solving O-Level Physics Paper 1, Variant 1 from October and November 2022. So let's get right to it. So the first question states that the diagram here shows three forces acting on a block. The resultant force is 6 newtons to the right. Which additional force produces a resultant force of 3 newtons to the left? So initially the resultant force is to the right and it's 6 newtons. We can check that as the using formula. The force on this side minus the force on this side. So 11 minus 3 plus 2. This gives us 11 minus 5, which is 6 newtons. Okay, so we have 6 newtons to this side. So the right now the force on the right side is larger than the force on the left side. So we need the resultant force to be on the left and also the magnitude to be 3 newtons. So we need to add something up here. So let's consider this force as x. So we need the resultant force to be 3 newtons. So let's put this resultant force to be 3 newtons. So using the formula, 3 newtons should be equal to the subtraction of these two forces. So there's this total amount of these forces. So x plus 3 plus 2 minus 11 newtons on the right side. So if you equate this, which would be x plus 5, and there it goes. 11 plus 4 is 14, so x will be 9 newtons. And since this 9 plus 5 is 14 newtons now at this side, so the resultant force will be on the left. So it's 9 newtons to the left. So this is our answer. Okay, so let's move on to the next question. It says velocity is given by the change in displacement divided by the change in time. How many vector quantities appear in the statement? Now, if we recall what a vector quantity is, it's the quantity that shows both magnitude of the quantity it's showing and also the direction. So we need these two things in our quantity for it to be a vector. So let's see in the statement, velocity. Let's find the quantities first: velocity, displacement, and time. These are the three quantities present. And now let's look at velocity. Velocity is essentially the change in displacement. Now, displacement, we all know, is a vector quantity because it can show direction. It can be a direction. We can show it, for example, we can show it as displacement from position x to the left, position x from x to the right. So it can show the direction. And velocity itself is change in displacement. So this is a vector quantity. Displacement itself is a vector quantity. And time doesn't show any direction. It only shows magnitude. So this is a scalar quantity. So only two vector quantities appear in the statement, which are velocity and displacement. So C will be the correct answer. Let's move on to the next question, number 3. It shows a car of mass 1000 kg is traveling down a steep hill. The brakes fail and the driver uses a horizontal sand-filled safety road to stop the car. Okay, the car enters the sand at a speed of 10 meters per second and experiences a constant stopping force of 2,500 newtons. So this force basically stops the car. Okay, so how far does the car travel in the sand before coming to rest? Okay, so in this, let's consider what happened in the sand first. So at sand, the car enters the speed of this, right? It experiences a constant stopping force of 2,500 newtons, which stops the car. So basically, the car does a work against this force, and that causes the car stop in the sand. So a work is done against this force. So for a work to be done against this force, the same and equal force needs to be applied by the car. So the work done by the car against this force in the sand would be if you recall, work is equals to force in the distance and the application of force. So work is essentially in this case 25,100 newtons into D. Alright, this is the work done by the car at sand. Now we need to find this D. This would be our answer. So how far does the car travel in the sand? So this work done. Now, okay, let's first look at the first part of the question now. The car has a mass of 1,000 kg, and then it enters the sand at 10 meters per second. So it travels down the hill at 10 meters per second. So when it's moving at a speed which changes to 10 meters per second, it means that the car has a kinetic energy. All right. If we remember the law of conservation of energy, which states that energy cannot be destroyed nor created, it can be transferred from one form to the other. So this kinetic energy, the whole of this kinetic energy essentially converts into the work done against this 1,500 newtons force. So basically, the kinetic energy converts into this work done, which is also an energy, right? So we can now write the equation as kinetic energy is equals to work done, which is force into distance. So if you remember, the formula for kinetic energy is half mv squared. So half mv squared is equals to the force, which is 2,500 into d. So now just put the values up here. 1,000 into 10 squared. This is 2,500 into d. Now if you equate this, the d will be 20 meters, I think. Yeah, this 20 meters. So this would be our answer. So the main thing is the kinetic energy gets converted into the work done in the sand, which actually causes the car to stop. So now let's move on to the next question, question number 4. Which part of the distance time graph shows the fastest constant speed? Alright, so distance time, what information can a distance time graph give us? So the gradient of a distance time graph can give us the speed. So the gradient gives us the speed. So shows the fastest constant speed. So we have to find the fastest possible speed that is constant. So constant speed means the constant gradient. So a constant speed graph would look like this. It would be a straight line. So we need to find a straight line that has the highest possible gradient. And here highest possible gradient basically means it would have the steepest possible line. So these are all lines up here, so we don't need to worry about them being curves. So the steepest possible, or the point with the highest gradient, would be C. This is the steepest possible part. So C would be our answer. Can just mention that speed is the gradient of the T curve. Displacement time graph. Okay, now let's move on to the next question. A graph of increasing gradient. So this will be our answer. Question number 6. What causes the frictional effects experienced by a cyclist to increase? Okay, let's go over the options one by one. A says using a lighter bicycle. So a lighter bicycle means the mass is less. So due to the less mass, the inertia will be less. So due to less inertia, the force required to stop the bicycle will also be less, or the frictional force in other words. So F, or the frictional force, will be less in this case. But the question asks for the frictional effects to be increased, not decreased. So this one will be our answer. So let's see B. B says traveling at a greater speed. Traveling at a greater speed. So basically, the speed of the bicycles has increased. So there is acceleration. So due to acceleration, there is force. The resultant force on the object also increases, which means the the frictional force or the force required to stop the object will increase. So in other words, for any object, if the speed increases or with increasing speed, the frictional force of such as air resistance or the friction with the tire and the ground will also increase because the total force that drives the object or the resultant force, in other words, also increases. So yeah, this is a probable answer. So let's see for for option C, which says smoother tire surface. So if the tire is smooth, then it will be difficult to stop the car. In other words, the frictional force between the tire and the ground will be more. So yeah, so the frictional force actually increases. The frictional force decreases in this case. So this will not be an answer. As a road surface covered in oil, it's the same as option C. This means the oil, since oil is a slippery substance, the frictional force will decrease. So the only probable answer is B. Let's move on to question number 7. The diagram shows a car at the moment the driver sees a hazard ahead. Which expression is equal to the stopping distance? So if you recall, stopping distance, stopping distance is basically the distance traveled by the car during a person's reaction time and or the thinking distance uh, and the distance the car travels while it's braking or while the car is braking. So essentially, it's a summation of between these two quantities. Well, let's see which of this option matches with our concept here. It's only A because all the others show different symbols. This is the addition symbol, so this is the answer. All right, a planet orbits the sun. The planet moves in a circular path at constant speed, but is accelerating because it is changing direction. In which direction does the resultant force act to cause this acceleration? All right, so this is a typical question regarding circular motion or centripetal force. So if I redraw the diagram here, this is the sun and this is the earth. As we all know, the sun and the earth has a attractive force to them. The gravitational force of the sun pulls the earth towards it. So if this force, in this case, this gravitational force is actually the centripetal force. So if this centripetal force wasn't present, then the object, the planet, would have moved it at a tangent to the circular path. But because of this force, it moves in a circular motion. So this is actually the force that causes this change in movement. So this centripetal force of the centripetal present here, or the gravitational force of the sun, causes the Earth or the planet, in this case, to move in a circular path. So in this case, the force that's similar to the arrow I gave here, the arrow that is perpendicular to the sun is D. So the answer is D, because this is the force of attraction, the specific force that causes the planet to move in the circular path. So that's why D is the correct answer. So X is the result of Y divided by Z. Well, what are X, Y, and Z? Okay, so let's write it down. X is equals to Y divided by Z. First option is mass, weight, and dimension of field strength. In fact, all the options contain these three quantities. Now, before going to that, let's first remember the relationship between these quantities. So weight, the formula was weight is equals to mg, where weight, W is weight, m is mass, and g is the gravitational field strength. So if it's division divided by z, we can write that mass is equals to weight divided by gravitational field strength. Let's look at the first option. It says x is mass, y is weight, and c is gravitational field strength. So yeah, if we correct this is weight, this is g, and this is m, so it all matches with our formula up here. So A should be the correct answer. If you look at the other options, they're wrong. Weight isn't mass divided by gravitational field strength, and likewise C, all of them are wrong as well. So A is the right answer. Question number 10. The question number 10 says, the graph shows how the extension of a spring changes with the masses suspended from it when the spring is on planet X and the spring is on planet Y. So we are talking about two different planets up here. So the quantity that will be different for these two planets is G, or the gravitational field strength. So gravitational field strength of X will be different from the gravitational field strength of Y. So if this is X, let's say GY. So then we have a graph of extension against mass. Now, if you recall from elasticity of springs, force of the we call Hooke's law, which states that extension is directly proportional to the force of the load applied to the spring until the elastic limit is reached. And from that we can derive the formula F is equals to Kx, where F is force and X is the extension and K is the spring constant. So in other words, we can write force is directly proportional to X. All right. Now let's find out what the force here is. It talks about it talks about masses. So the force of mass can exert is Cp, the weight of the mass. So weight is equals to mass into mg. In other words, given the mass is constant, but mass doesn't change in different planets, so it remains the same on every planet. So mass is constant. Given that mass is constant, we can write weight is directly proportional to g, and we can just replace this w with f because its weight is a force. So force is equals to g. Directly proportional to g, and since this is f is directly proportional to extension, so we can also write that extension is also directly proportional to gravitational field strength. So this is the main thing derived from these steps. So let's move on. Now let's move on to the options. It says it's not possible to compare the gravitational field strength of planet X and Y. Now we can compare since X extension is directly proportional to G. So any change in extension will affect the gravitational field strength the same. For example, if the extension increases by 2 times, then the gravitational field strength will also increase by a multiple of 2. So yeah, we can actually derive that from these. So yeah, this is one option. The gravitational field strength on planet X is equal to the gravitational field strength on planet Y. So let's actually go try this out. Okay, so let's find out a fixed mass first. Let's take 2 kg. So at 2 kg, the extension of the mass at Y is 10, and for X is 30. All right, so we can see there's X is 30, Y is 10. If we ratio them 30 by 10, then 3 get 3. So in other words, we can write the extension of X is equals to 3 times that of y. So, extension is directly proportional to gravitational field strength by that g, or the gravitational field strength of x, is 3 times the gravitational field strength of y. So it's not equal, it's actually 3 times greater than y. So this is wrong. It's 1/3. No, it's 3 times. So this is wrong as well. Gravitational field strength on planet X is 3 times the gravitational field strength on planet Y. Yes, this is correct. And so the answer would be D. Okay, so let's move on to question number 11. It states a uniform beam is pivoted at its center. Two weights are placed on the beam in the position shown, and the beam is balanced when up force of F. So this is a typical question for moment or turning effect of forces. So if you recall the formula for moment, it's moment is equals to moment about a pivot is equal to the force into the distance between the force and the principle that also states that counterclockwise moment, clockwise moment is equals to anti-clockwise moment for an object in equilibrium about a pivot. And yeah, so we use this formula up here, convention up here, to solve this. So let's write these out first. So clockwise movement is equals to anti-clockwise movement. So the clockwise movement, in this case, clockwise, basically, it's this direction. So the only force that's in the clockwise direction is the 60 Newton force, and this causes a moment of 60 into 30. So 60 into 30 because it's the distance between the force and the pivot. Since there are no other clockwise movements, let's move on to anti-clockwise movement. Anti-clockwise direction, anti-clockwise movement is this way. So this is one of that, and the other F itself is in the anti-clockwise direction. So S into the distance between S and the pivot, which is 330 plus 20, so that's 50 centimeters. So S into 50 plus the moment caused by the 30 Newton force to a 30 Newton weight, which is 30 into 40. So 30 is the force, then the perpendicular distance, which is 40. 12 newtons. That's the answer. Let's move on to question number 12. It says 4 objects of equal mass rest on table. The center of mass of each object is labeled G. So which object is the least stable? So for questions regarding stability of objects, we need to consider 2 factors, which are base area of the objects and the height of the center of mass from the ground or the base. So for an object to be least stable, we need the base area to be as low as possible. We also need the height of the center of mass to be as high as possible. So we need something that has a low base area and center of mass as high up as possible. So let's see, the lowest or the smallest base area is for B, and B also has the center of mass, the highest point. So this is higher than all these. So B will be our answer. So let's move on to question number 13. Each tire of a car has an area of 100 centimeter cube in contact with the ground. The car has a mass of 1600 kg. The weight of the car is equally distributed amongst the 4 tires. The gravitational field strength G is 10 Newton per kg. What is the pressure exerted on the ground? So if we exert on the ground, if we remember the formula for pressure, it's P is equals to force divided by area. So let's find out the force first. So the car has a mass of 600 kg, which means it has a weight of 16,000 because the G is 10, so 1600 into 10, 16,000 is our force, and our area is, each tire has an area of 100 centimeter cube. Since the car has 4 tires, so the area will be 4 into 100, which is 4 cm cube. So that means the area is 400. Now if you equate these, you'll get 40 Newton per centimeter cube. So C is the answer. So now let's move on to question number 14. Question number 14 says the pressure P of some trapped air is varied. The mass and the temperature of the trapped air remain constant. Which graph shows how the volume V of the air varies with pressure P? So if you remember Boyle's law, it states that pressure is inversely proportional to volume. So we write this as this, that inversely proportional relationship. We write this in this form, which can be also said as pressure is directly proportional to inverse of V, or 1 by V. So this necessarily means that if pressure increases, volume will decrease. Likewise, if volume increases, pressure will decrease. So let's see for our options here. So A says that it shows a graph P against 1 by V. So it says that if 1 by V increases, then P is also increasing. Now it actually matches with the convention the concept we draw up here, which says it's directly proportional to 1 by V. So if 1 by V increases, then P also increases. In other words, we also can write this as if pressure increases, then volume decreases. So this is actually correct. Now if you look at the other options, it says P is a graph of P against V, and it shows a directly proportional relationship. So it says that if V increases, then P also increases, which is not the case, so it's wrong. There should be inversely proportional. Now this is practically the same as this curve, so this is wrong as well. This is a curve of P against 1 by V. No, for 1 by V should be directly proportional, but it shows that inversely proportional relationship. It shows that if 1 by V decreases, then P decreases. Increases, and P decreases if 1 by V increases. So this be wrong as well. So A is the only correct answer. Let's move on to question number 15. So question number 15 says a constant force F pulls a block of weight W up the slope shown. A bunch of different symbols appear, and the diagram. The question says how much work is done by F in pulling the block up the slope. Now, if we ask for the work done, specifically done by the force F. Now, if we recall formula for work done, it says work done is equals to force into distance moved in the application of force. So the distance that we will consider here will be only the length or the distance that is moved by the object in the direction the force is exerted on it. So let's see up here. So we have two forces, F and W, to consider. So if we look at W, the force on the object is downwards. But we see that the object doesn't move downwards. So it doesn't travel the length of h. So In our case, the work done won't be force into W. So let's consider L now. L and F. So the force is in this direction, and the object also moves parallelly to the length of the ramp, or L. So the force moves in the direction of L. So we can write that F into L is the work done. And in the question, when naming the options, we also have B as the correct answer, as it shows F into L. F into H would work since H is downwards and F is in a different direction. So we showed that this won't be the right answer, and this obviously won't be the right answer as well. This F. L is in an inclined position, W is downwards. So B is the correct answer. Okay, so now let's move on to question number 16. Question number 16 states X and Y are both 40 watts to 40 volt lamps. Lamp X is more efficient than lamp Y. Which statement correctly compares X with Y? So the key word up here is efficient. Efficiency necessarily means useful energy output divided by the total energy input. In other words, its efficiency is the amount of total amount of energy input that is converted into useful energy output, or useful energy for the lab. Now it says a lab X is more efficient than lab Y. That means more useful energy output is produced for lab X than lab Y. Now let's consider the options up here. A says X is more expensive to run. Well, in the case of X, we can say that it produces more its useful energy out. In other words, it means that more of the total energy input is converted to useful energy out. So for X, less total energy input is required to produce the same amount of useful energy output when compared to Y. That means we need less total energy for X to run, which means it should be less expensive, not more. So this is this is let's say so X should be less expensive to run rather than being more expensive. So this is the wrong statement. So B, and I'll go on to B. You say the low electrical resistance. Well, none of the quantities up here, the information up here actually tell us this. So let's keep that on hold or cross it out together. Then C says it produces less light energy. That's not true because they're both rated at the same quantity, 40 watts and 240 volt amps. So they produce the same amount of light energy. So this is wrong as well. Then D says X produces less thermal energy. Now, most of the energy that is lost is always in the form of thermal energy. So we can say that this thermal energy that's produces a loss of energy to the surroundings. So since X is more efficient, the loss of energy for lab X would be less. So yes, this is correct. So D is our answer. So let's move on to question 17. So question number 17 says, the diagram shows a radiator, the air in a room. Alright, so what is the name of this process? So normally in cases dealing with the transfer of heat through air, we always consider the process of convection. As this is the fastest process that can transfer heat through the air. Now, if we recall, convection is what occurs when the heat when the heat source heats up the air in front of it, making it light and hot, which causes it to move upwards. Now the cold denser layer, denser air comes down and replaces the position of the light hot air. So this actually creates a cycle or current, which is known as the convection current. Now let's see if these arrows match with the diagram up here. Hot air moves up and the cold air moves down. So yeah, it does match it. So this is an example of convection. So this will be our answer. Please answer. So let's move on to question number 18. What is the process of heat transfer that can take place in a vacuum? So all the process of heat transfer need some medium or molecules to pass through except radiation. D is the right answer, because radiation occurs through electromagnetic waves, magnetic waves, now specifically infrared. So D will be our answer. Okay, let's move on to question number 19. Question number 19 says the diagram represent 4 thermometers, PQ, R, and S, for which thermometer has the greatest sensitivity and which has the greatest range. Now let's work on the range first. Let's see which has the greatest range. So the range for this would be 25 minus 0, which is 25 degrees. And for this, 40 minus 30 degrees, which is 10 degrees. And for ours, 250 minus 0, which is 250 degrees. And for S, it's 300 minus 100, which gives me 200 degrees Celsius. So the highest range among these 4 thermometers belongs to thermometer R, so these two could be our probable answers. Then let's find out the greatest sensitivity. So sensitivity is basically the measure of this sensitivity. So let's find out the sensitivity. So the higher the sensitivity of thermometer, the higher will be the change in the volume of the liquid or the level of the liquid for a small change in temperature. So for example, let's take a sample change in temperature, let's say 5 degrees Celsius. Okay, so for thermometer P, a change of 5 degrees Celsius or 5 degrees will be this much. So let's note that down, this will be this much. And for Q, a change of 5 degrees will be halfway through the thermometer. So it is a quite significant change for 5 degrees. And for R, a change of 5 degrees will be quite insignificant. I write it out here. And for R, it's quite significant as well. So the most significant change for a small change of changing the level of the liquid thermometer for a small change, 5 degrees, is the highest in thermometer Q. So Q and R would be the answer, where the sensitivity will belong to Q and where the range to R. So C is the right answer. So move to question number 20. A piece of iron of mass M is placed in a mixture of ice and water. Its temperature decreases from theta 1 to theta 2. How much thermal energy is lost by the piece of iron? If you recall the formula for the energy change due to temperature change, it's E is equals to mc delta theta, where M is the mass. This delta theta is change in temperature. and C is basically the specific heat capacity. So let's see uh, if the M, so let's put the quantities up here. So M into the C heat capacity of iron into the changing temperature. So as it decreases from theta 1 to theta 2, you can write this as theta 1 minus theta 2. So this would be the amount of energy that is lost by the piece of iron. So if you compare this to our options, BA says M into specific capacity of iron into this. So this is the MC delta theta, so it matches with our formula. So the right answer. If we look at the other options, it only multiplies it. This will be only multiplies with the temperature, not the change. So it won't be our answer. C also does something wrong, which is it uses heat capacity, but in formula we use C, which is the specific heat capacity, which is quite different because it doesn't consider um but the mass in this case. So and D does the same thing. Also a mistake on this end as well. So it will be our answer. So let's move on to grade 1. A kilogram of a substance has a fixed shape. The thermal energy supplied to the substance weakens the force of attraction between its molecules. What is happening? So the first statement we can say, it says it has a fixed shape. It's the only form of substance that has a fixed shape is sunlight. So it isn't a liquid because liquid fills the container, shape of the container it is in, and gas obviously doesn't have a fixed shape. So right on the bat, we can see 1, 2, 3, all the three options are wrong since it doesn't have the solid up here. And D has the solid mentioned, and it says it is at its melting point. At melting point, thermal energy that is supplied is used to weaken the force of attraction between the molecules, so that the state conversion occurs from solid to liquid in this case. So D is the answer. So number 22 says which conditions produce the greatest rate of evaporation from a liquid. So in the case of evaporation, we need to consider three factors. Three factors are, number one is the temperature, obviously. Two is surface area of the liquid, surface area. And three is humidity or the moisture of the atmosphere around the liquid. So this the question asks for the greatest rate of evaporation. For the greatest rate, we need the temperature to be as high as possible, surface area to be large too, and humidity to be less. Because if the air is more humid, then there's less space for water molecules to evaporate in. So we need a humidity that's less than the humidity is relatively less. So let's consider the options now. A says high temperature. Yes, we need that. And also it's drought. Drought means the lack of rainfall, so there will be no rain. So that means the air will be less humid due to rain and evaporation. From the evaporation of the water molecules of rain, the humidity usually increases. But since it says drought, there is no rain. As a result, the humidity will be less. So this is a favorable condition too. And large surface area of the liquid, which is also favorable for the greatest rate of evaporation. So A will be the answer. And if we look at the other options, it says no drought, which means humidity will be high. Don't want that. And for C, low temperature, just not favorable. Low temperature up here too, so these two are wrong. Well, B. So A is the right answer. Let's move on to question number 23. Which statement is correct? It says both longitudinal waves and transverse waves can travel at the speed of light. Well, only electromagnetic waves or T waves, the electromagnetic spectrum, travel at the speed of light. Waves only. So longitudinal waves do not travel at the speed of light. Transverse wave do, but not all of them. The electromagnetic waves do. So this is wrong. So B says both longitudinal waves and transverse waves of similar wavelengths must have similar frequencies. Well, V call formula of velocity or the speed of a wave is V into F lambda. V is equals to F lambda, which is frequency. So frequency is dependent upon both velocity of the wave, or the speed of the wave, and the wavelength of the wave. So it's not necessary that the wave with similar wavelengths must have the same frequencies. Frequency is often unique for each wave, and it also depends on the speed of the wave. And the frequency of waves usually remain unchanged unless a source is changed in one way or the other. So B is a correct answer. C, the correct statement. C says both waves and transverse waves can travel in a vacuum. That's wrong. Is wrong as well. Only transverse waves can, longitudinal waves cannot. Then D says that both longitudinal waves and transverse waves can travel in water, which is true because water waves themselves are transverse waves, like a net ride. Transverse waves can travel in water, and longitudinal waves, example would be sound wave, and sound wave can also travel in water. So D is correct. So let's move on to question number 24. 24 says a mirror is placed in the path of a ray of light. Through which angle does the direction of the ray of light change? Through which angle direction of the ray of light change? So this is an example of reflection. So quite clearly mentioned here, this is the reflected ray. Now if we recall the for reflection of waves, the angle of incidence is always equal to the reflection, like the angle of reflection. So this means if this is 40 degrees, then the angle of reflection, the angle between the normal of the reflected ray, will be 40 as well. So A is the correct answer. So let's move on to number 25. An oscilloscope is used to demonstrate a sound. Okay, which feature of the oscilloscope trace is affected by the quality of the sound? All right. So let's draw the presentation of oscilloscope first. So it basically looks like this. So it says the quality of the sound. So if the quality of the sound is changed, then the oscilloscope will have something like this. The shape distorted because of the poor quality, or if it is for poor quality, then the shape will be like this. So if the shape is distorted, is the amplitude changed? Now, the amplitude is necessarily the maximum distance from the equilibrium position to either side of the equilibrium, the maximum distance or the maximum length. So the maximum length will not change because the wave will always reach the maximum there at one point or the other. So the amplitude remains unchanged. Frequency is the number of oscillations per second or per unit time. The number of oscillations or the number of waves passing through a point will remain the same. But if you remember, this is the time base and this is time base, x-axis is the time base, so it remains the same. the frequency doesn't change as well. Now shape, and I've been constantly using the term shape. Yes, it's shape of the wave did change. So this could be a viable answer. Wavelength is distance between several points in a wave, and it remains same as well. So this is also a wrong answer. So C is a correct answer. Okay, so number 26, it says 4 floating compasses are placed near a bar magnet. Ignore any effects of the Earth's magnetic field. One compass appears like this. What is the possible position for this compass? So it should point downwards. So let's first draw the magnetic field lines on the magnet. It would be something like this. Should be like this. So since field lines move from north to south, the arrows will be pointing in these directions. So what that should point. So let's go over them one by one. At A, the arrow will be pointing this way. At B, it will be this way. At D, it will be towards the left. Now at C, you could say that points in the direction like this. Now, if you see that C is the only arrow that's similar to the one given in the question, so C will be our answer. So let's move on to 27. A plastic rod and a cloth are initially uncharged. The rod is then rubbed with the cloth and the cloth becomes positively charged. What is the sign of the charge? Plastic rod, and why does it charge? Okay, so it says the cloth becomes charged, negative, it says positively charged. So the cloth is positively charged when it's rubbed against the rod. If this is positively charged, that means electrons lost from the cloth. So since they're lost, they have to be gained by some other object. Since it was rubbed with the plastic rod, this means that it has gained the electrons. So it has excess of electrons. Plastic rod now has an excess of electrons, which means it has become negatively charged. So charge on the rod would be negative. Now how did the rod become negatively charged? Then electrons move from the cloth to the rod. So A will be the right answer. So B, why wouldn't B be the right answer? Because it says protons move from the rod to the cloth. Okay, first of all, protons never move, only electrons. So this is wrong in the first place, but it also says moves from the rod to the cloth. So yeah, it says protons don't move, so that's incorrect. So B will be the answer. A is the correct answer. So let's move on to number 28. 28 says, which expression gives the electromotive force or EMF for battery? So if you recall, EMF is the work done, the energy required to drive a charger out. Charge a single charge out circuit. So it's by work done, or in other words, we can write work done per unit charge. So this can be as work done divided by charge. So the only one that's similar to the formula we derived is D. So the formula doesn't have any relationship with time. So A and C won't be correct, and it obviously isn't the multiplication of these two quantities. So D will be the answer. Okay, now let's move on to question number 29. So it says a circuit contains two cells and two lamps. The cells are new and fully charged. In which arrangement of the cells and lamps the cells discharge most quickly? So the keywords up here are discharge and most quickly. So the cells are fully charged initially, and the question asks us to find the arrangement where the cells lose their charge the fastest. So if you analyze the quantities mentioned here are charge and quickly, which means time. So if you recall the definition of what a current is rate of flow of charge. So essentially, we have to find the arrangement of cells where the current is the highest or the maximum value. So for the current to be highest, we need to consider two factors, which are the voltage or the EMF and the resistance of the circuit. So let's work on resistance first. So for the current to be the highest, the resistance has to be increased. So as the resistance decreases, the current increases. So let's find the circuit where the resistance is at the lowest value. So the resistance, each of the lamps has their own resistance. So if we look at these diagrams, we can see that there are two types of connections: parallel and serial, right? So as we all know, in serial connection, the total resistance are just added up. And in parallel connection, it's a different formula, which is basically we have to first add the inverse of the resistance, and then inverse the result to get the result. Inverse this result to get the final result of the total resistance. So in these two cases, we will. It's not that difficult to notice that serial connections usually have higher resistance than parallel connection. If we compare between these two connections, so we need to find a connection that is parallel, the connection between the trying to find a circuit where the connection between the lamps are parallel. So the only two of them are A and C. Parallel connection means they have the lowest resistance possible. So we can cross these two out. Now we've considered the case for resistance. The lowest amount of resistance possible are in A and C. Now let's consider the case of EMF, or the total voltage across the circuit. So we need, as we can recall, voltage is directly proportional to current, which is Ohm's law, right? So we need for a high amount of current, we also need a high amount of voltage or EMF. Basically, we need the highest possible EMF. So let's look at these two diagrams. You can see at A, the cells are arranged in parallel connection. This means in parallel connection of cells, only the value or EMF of a single cell is given out to the circuit, which means the total, if this is 3 volts and this is also 3 volts, then the total EMF of the circuit will also be just 3 volts. All right. So this is the case for parallel connection, but in C, it's a serial connection. In a serial connection of cells, the EMF or the voltage of each cell is added up to get the final EMF. So if this is 3 volts and this is 3 volts, the EMF would be 6 volts. Yeah. So this is the total EMF. So we can see that the EMF, the option of C, is the largest, and the resistance of this circuit the lowest. So these two factors combined gives us the maximum current possible, which means the cells will discharge the most quickly in this circuit. So C is the answer. So let's move on to question 30. So it says a lamp is connected in series with a battery and a variable resistor. The resistance of the variable resistor is decreased gradually. All right, so which statement is correct? Before we go into that, it says resistance of the variable resistor is decreased gradually. This means the total resistance of the circuit will also decrease if this decreases. Because this is a serial connection, the resistances are added up. So if the resistance of this particular component resistor decreases, then the total resistance of the circuit decreases. Now, if the total resistance of the circuit decreases, the total current across the circuit will increase because there's less resistance and components the current can pass through easily. That is why the rate of flow of charge, the current will increase. This is a fact we can derive from here. So which statement is correct? The current in the lamp increases. The AC lamp increases. Yes, the total current increases. The current across this lamp, into this lamp, will also increase. That is true. This is a correct statement. The current in the variable resistor decreases. Now it will also increase. So it is incorrect. The EMF of the battery EMF, the total EMF of the circuit is not affected at all. So this would be incorrect. The total resistance in the circuit increases, not decreases, as we found out. This is the correct answer. Yes, correct option. Okay, so let's move on to question 31. 31, it says in the circuit shown, all the cells are identical and all the lamps are identical. The switches are closed, right? In which circuit are both lamps the brightest? Okay, so for the lamp to be the brightest, we need the EMF or the voltage across the potential difference across the lamps to be greatest as possible. So we need the voltage to be, or the EMF to be greatest as possible. Or and I should say potential difference, the PD across each lamp should be the greatest as possible. Okay, so right off the bat we can cross A and C out because the circuit won't be completed because of this diodes which are placed in the opposite direction, so they are reverse biased. They should have been like this for the current to flow through the circuit, and because of this for the reverse bias direction, the current won't reach these lamps. So these two will be crossed out at first. Now let's compare between B and D. So in B we can see this is a serial connection. So in serial connection of components in a circuit, the voltage V is divided among the components, among these. So if the total EMF was 6 volts, then this could have been 3 volts and also these 3 volts. Let's consider option D here. And this is a parallel connection. So the V is same, or the PD, we should say, the PD, a potential difference. This is same. So if this was 6 volts, then this would also be 6 volts, and say 6 volts. The PD across these two lamps would be 6 volts. So basically, here, this PD will be divided, but the EMF will be divided, and here it won't be. So D would be the correct answer, as it will give the highest voltage possible, and this highest voltage would give us the brightest lamps. All right, so let's move on to the next question, which is question 32. Why is a fuse used in an electrical appliance? So fuse is normally used as a safety equipment, which protects from electric shocks. Electric shocks, which can ultimately damage the person or the user or the appliance itself. So let's see the options. Turn the appliance, no, to change the power of the appliance, no, as well. Change the voltage, no, as well. So various is. Question number 33. So which statement about a transformer is correct? Let's first recall how a transformer works. A transformer is used to increase or decrease the voltage along long transmission of electricity. So this is the soft iron core. It's connected, one end is connected to the primary coil, which is connected to an AC supply, AC current. The other end also has coil wrapped around the iron core. It can be termed as a secondary coil, where the voltage can be increased or decreased. So because of the AC current, a magnetic field, a changing magnetic field is produced in the coil, which is channeled through the soft iron core to the secondary coil, where due to change in flux linkage and EMF is induced. Now, this EMF will depend on the number of coils here. So let's see our the options up here. It says the changing magnetic field in the transformer induces an EMF in the secondary coil. The changing magnetic field, yes, that is correct. This is an AC current for which the magnetic field changes. And yes, due to the flux linkage, due to this magnetic field, an EMF is induced. So this, the secondary coil. So this is correct. Let's see the other options too. The core of the transformer is made of iron because iron is a good electrical conductor. For this case, we will consider it as a magnetic conductor, not electrical. So this is wrong. C says the transformer converts alternating current to direct current. Now the current remains same, and this is a similar statement. So these two are wrong. A will be the correct answer. The diagram shows the let's move on 34. The diagram shows the output from an AC generator displayed on an oscilloscope screen. The generator is turned at a slower rate. The settings of the oscilloscope controls are not changed. Which diagram shows the new in output? So the only thing that's changed is the motion of the generator. So it turns at a slower rate. So let's first draw the representation of oscilloscopes. This is the time base and this is the voltage. Alright, so this is our initial figure of the oscilloscope. So if it's turned at a slower rate, means the frequency or the number of oscillations per unit time per second will be less. So the graph will look like something like this. So there will be less number of wavelengths in 1 second. And that's one change, but there will be also another change, which is due to the slower movement of the generator, the voltage that the EMF that is induced in the coil of the generator will be less, because the motion of the change in magnetic flux linkage will be less. So the induced EMF also decreases, for which the amplitude will also decrease. So it will look somewhat like this. So it was initially at a point like this, but due to the change in voltage too, the amplitude also decreases. So the graph that's similar to the one I drew here, it's B. The answer would be. If you look at the other ones, here the amplitude is increased, so which won't be the case in this case. Well, the amplitude only has changed, it has decreased, but the frequency remains same. So the answer, and here the frequency has increased, which is definitely not the case. So yeah, B is the answer. So let's move on to question 35. So question number 35, the sound wave produced by a note is displayed on the screen of a cathode ray oscilloscope. The time base is set at 5 milliseconds for one division. So one division up here is 5 milliseconds. So what is the frequency of the note? Right, so frequency is the number of oscillations per unit time. So number of oscillation or number of wavelengths or number of single wave per single point by unit time. So per unit time is usually 1 second, right? But we have one division as 5 milliseconds, so it's quite impossible to actually figure out the frequency just by looking at the diagram. But we can definitely figure out the time period of one wave, then use the formula of frequency is equals to 1 by time period to get the value of the frequency. So let's find the time period. Time period is the time taken for one wavelength to pass a point. So basically time taken for one wave. So let's mark one wave. So this is the starting point, it's the ending point. So this is one wave. So this is 5, 5, 5, 5. So 5 into 4 is 20 milliseconds. Now, if we have to convert this into seconds, so 20 in 10 into 10 to the power of 93 seconds. So let's just input this up here, 1 by time period, so 1 by 20 into 10 to the power of minus 3 seconds time period. So this will give the answer as, so B will be our answer. Now let's move on to the next question. Three types of three types of radiation emitted by unstable nuclei are helium nuclei, short wavelength, electromagnetic waves, and electrons. What are these types of radiation? Okay, so right on the bat, we can say that helium nuclei is alpha radiation, and short wavelength electromagnetic waves. So we have three types of radiation: alpha, beta, and gamma. It's the only radiation that's electromagnetic wave. So an electromagnetic wave is gamma. So this is gamma. And electrons, it's obviously beta particles. So helium nuclei as alpha, electromagnetic waves as gamma, electrons as beta particles. So yes, 36A. Okay. So let's move on to question number 37. It says a beam of electrons is fired into a uniform magnetic field as shown. The direction of magnetic field is into the page, alright. Which the page, which part of the what do the electrons fall? So here we have to use a Fleming's left hand to actually solve this problem. If we recall Simons like Unreal, which is this, where Fleming's left hand rule, the thumb will be the force of the motion, the next finger will be the direction of the magnetic field, and the middle finger will point towards conventional current. So the thing we have to be careful on, the particle that's been fired is an electron. So electron is the opposite of conventional current. So if the electron is moving to the right, then the conventional current would be at the opposite direction. The conventional current will be pointing this way. So if we now rotate our hands likewise, then the force will be downwards. So our thumb will be pointing downwards as the magnetic field be into the page. So now the confusion could be between D and C. So the answer would be D here. At C, it shows a sudden and direct turn from a specific. Now, the electron beam is already fired at a specific force, so it has a force of its own that's moving in this direction. Now, the deflection produces a force in this direction. So, due to this, a resultant force is produced, which is why the direction the electrons would be curved instead of a straight line like this. So yes, the answer is D. Let's move on to question 38. Which statement about all three types of radioactive emissions is correct? Alright, so they are all completely absorbed by a thin aluminum sheet. This is wrong, as gamma can pass through. And number B says, option B says they are all deflected by electric fields. The only charged particles can be deflected by electric and magnetic fields. So gamma is an electromagnetic wave. So gamma rays don't. So rays don't. They are all deflected by fields, which is gamma rays don't get deflected. And last option says they all cause the ionization of gases. Now, ionization basically means they react with the gases and there's a sharing of electrons, a transfer of electrons, which is true for all kinds of radiation. So this is the answer. So number 39, what is meant by the half-life of a radioactive substance? Okay, so half-life, if we recall, the definition of half-life is half-life means the time taken for number of atoms to pass. So let's match this with the definitions up here. Half the time taken for all unstable nuclei decay. True, but correct. This says half the time it takes and unstable nucleus to emit radiation. This is also not correct. Time for half the unstable nuclei to decay, also not correct. The last option says the time taken for the nucleon number to half, which is true. Well, let's move on to question number 40. Radioactive isotopes that emit alpha particles, beta particles, and gamma rays are stored in wooden boxes that are lined with a material that prevents most radiation escaping from the box. So which material is used for the lining? Now it has to be a material that prevents most radiation escaping from the box, which means it prevents radiation from all three of the radiations we have: gamma, beta, and alpha. So let's see the materials we have here. Copper can stop alpha and beta, but not gamma. Beta can also pass through. Some of them can pass through. Glass cannot stop beta and gamma rays, and plastic as well. So the only possible answer is lead, which can stop gamma rays, and obviously beta and alpha rays as well. And so that's the end of the paper. Thank you for watching.